Okay, welcome. Today we'll talk about rationalizing the denominator. One thing in math we do not like is having a square root or a radical sign in your denominator. So I've got about 10 examples, and these are simple examples of rationalizing your denominator. So whatever your denominator is, what you want to do is you want to always multiply the top and bottom by that denominator. So 1 times the square root of 2 is just the square root of 2. But now you've got this. Think about this. Square root of 2 times square root of 2 is the square root of 4. Now, square root of 2. So what is the square root of 2? It's 2. So this right here would be my answer. Now, for me, another way to look at it is when I get to this step right here and I do the square root of 2 over square root of 2, I know that a square root of 2 and a square root of 2, if you multiply by itself, it automatically gives you 2. So if you have a pair of a square root, you can just bring that out to whatever number's underneath of it. It's the same as multiplying square root of 2 times square root of 2 to give you a square root of 4. Okay, next. And at any point during this video, you can always pause it and see how you've come up with your answer, and then unpause it to see how I work it out. Now, I'm looking at right here, I need to multiply both by the square root of 3. So in this one, 1 times the square root of 3 is just the square root of 3. Now this is 3 times 3, so you can say that is a square root of 9, which is square root of 3 over 3. Now notice one thing too is we're not having a square root in the bottom in our denominator. Now what happens if you have 3 over the square root of 5? Well, we still follow the multiply the top and the bottom by the square root of 5. But now you're going to say, okay, this is 3 times the square root of 5 over, and since I've got two pairs right here, and I know 5 times 5 is 25, and the square root of 25 is 5, so see, that number is the same, so that's my number. This right here is as far as you want to bring it down to. Same thing with this one. Multiplied by the square root of 7, top and bottom. So it gives me 9 square root of 7 over, okay, so think about this, 7 times 7 is 49, that square root. So see that number right here, you just have to take one of them. This right here is my answer. Multiply by the square root of 5 on both top and the bottom, and I got 10 square root of 5 over, now think about this right here, I got a pair, so that's why it's a 5. Now notice something, 5 goes into 10 2 times, so now my whole answer is, because they will want this in a reduced form, so it's 2 square root of 5. So I need to multiply the number 6 by the square root of 12 on top and bottom. So this is going to be 12 square root of 12 over, right here, both of them give you a 12. Now notice this right here. The 12s cancel. And you get the square root of 12. Now, be careful because you may have to reduce this square root of 12. And think about this for a second. 12 can be, and I'm looking for a perfect square factor, 4, so I'm looking at 4, 9, 16, 25, all the way up to 49, 81, and so forth. I'm looking for my perfect squares. So I know 4 times 3. So now what is a square root of 4? It's 2 that goes on the outside. What goes on the inside? It's a 3. This could be what they're looking for as well. To double check your answer, you always square the outside. 2 squared is 4, and then multiply by the inside is 3. It gives you, comes back and gives you that 12. Okay, so now I'm going to do the square root of 2 over square root of 2. That gives me 8 square root of 2 over 2. And then 2 goes into 8 4 times. This is my answer. Now notice 2, I cannot break it down. That's why I just leave it just like that. 10 square root of 12. So I'm going to multiply by square root of 12 over square root of 12. That gives me 10 square root of 12 over 12. Now, notice that 2 can go into both. So 2 goes into 10 5 times. 2 goes into 12 6 times. So that's 5 square root of 12 over 6. Now, if they want you to break it down, remember, right off the bat, if you want to keep this in your notes, the square root of 12 equals 2 square root of 3. So when I take this and replace it by this, you'd say 2 times 5 is 10 square root of 3 over 6. And now to reduce it now, 2 goes into 6 3 times. 2 goes into 10 5 times. So it's going to be 5 square root of 3 over 3. Okay, my last two, we're going to have to break down the answer a little bit more like what we have done in problem number 8. So I'm going to do square root of 24, square root of 24. That gives me 20 square root of 24 over 24. I know right off the bat that 4 goes into that 5 times. 4 goes into 24 6 times. So that's 5 square root of 24 over 6. Now, what is the square root of 24? Well, I'm going to put it over here. Square root of 24. Now, think of perfect squares. I'm thinking of 4. 4 can go into that 6 times. So then you take, okay, 4 is the perfect square, so it's going to be 2 square root of 6 now. So now I'm going to replace this right here by, so I'm going to multiply that by, say, 2 square root of 6 over 6, which that now gives me 10 square root of 6 over 6. And I know 2 goes into both 5 and 3. So my answer is 5 square root of 6 over 3. Now finally, I'm doing a 48 because I know 48 is a huge one that's got a lot of factors in it. So still multiply it by the square root of 48 on both the top and the bottom. You get 6 square root of 48 over 48. Now right off the bat, I can say, okay, 6 goes into 8. 6 goes into itself 1 time. 6 goes into 8 8 times. So that breaks down to 48 over 8. So now what is the square root of 48? Well, think of perfect squares. I can use 4 if I want to. My next square is a 9. I cannot use 9, but think about 16. 16 can go into 48 3 times. What is the square root of 16? It's 4. So this is what I'm going to replace this by, is I'm going to replace the square root of 48 by this 4 square root of 3 over 8. And finally, 4 goes into itself 1 time. 4 goes into 8 2 times. This is square root of 3 over 2. Okay, thank you for listening for my lesson on rationalizing the denominator.